Welcome to Maths with EJD. I'm still talking about coordinate geometry, and this is the second video on equations of lines. In the previous case, we had looked at line representation. Here, we want to look at parallelism and perpendicularity. Okay, let's go for that. Of course, when we talk about parallelism and perpendicularity, we want to look at what makes two lines parallel and what makes them perpendicular, and then we can now use that to take care of some other issues. Okay. So for parallel lines, to start with, two lines in the plane are said to be parallel if they have the same slope. Suppose line L1 has slope M1 and line L2 has slope M2. Then line L1 is parallel to line L2 if and only if M1 is equal to M2. So if you have two lines with the same slope, then the lines have to be parallel, right? But then there are special cases. So vertical lines, all lines of the form x equals a are parallel. Then horizontal lines, all lines of the form y equals c are parallel. Okay? So before we consider special lines like that, so any line, all lines of the form x equals a. So if we say x is equal to 5, and then we come here and say x is equal to minus 3. So you can see they are all parallel. X is equal to 4. Okay? X is equal to minus 3. Okay, I've done that before. That's minus, let me say minus 1 now. So you can see they are all parallel. On the other hand, all lines of the form y equals a constant, right? Say y equals 2. Okay? Say y equals minus 2, right? Y equals, if I say y equals 0, you see, even that, then y equals minus 1 over 2. Okay, they are all parallel in that case. Okay, so these are special cases. But let's look at the general case, the other general cases, right? Where two lines are said to be equal because they have the same slope. So imagine you want to check if the lines 2x minus 3y plus 5 equals 0 and 4x minus 6y minus 7. You want to check if they are parallel. You want to check if they are parallel. That's really important. So what you need to do in that case, you want to check, since it is slope that determines whether they are parallel or not. So you want to check their slopes out to see if they are the same or not. Okay, so that takes us to the worksheet. So we can go to the worksheet in that case and sort that out. Or, okay, I know that doing it, working it out can be more helpful. Of course, it's already done here, right? But I think doing it on the worksheet can just give some more clarity. Okay, so we want to check if lines 2x minus 3y plus 5 equals 0 and 4x minus 6y minus 7 equals 0 are parallel. How do you check? First of write the two equations in the form y equals mx plus c and have your eye on, and then you can have your eye on okay, then you have your eye on the slope. Okay. So here now you have 2x plus 5 equals, 2x plus 5 equals 3y. I'm taking the y apart, then divide through by 3. So you have 2 over 3x plus 5 over 3y. So in short, this equation is simply the same thing as 5 over 3 rather. 5 over 3 is equal to y. So you have that to be y equals 2 over 3x plus 5 over 3, like that. So this is what you have. And then this is the slope, 2 over 3 here. Okay, so with that in place, you can come for these two. So make y the subject. All right, write it in the form y equals mx plus c, like I said. So you have 4x minus 7 equals 6y. Divide through by 6. So you have 4 over 6x minus 7 over 6 equals y. So that you now have y to be 4 over 6 is simply 2 over 3. 2 here is 2 here is 3. That's 2 over 3x minus 7 over 6. So the question is, Okay, not then the slope here is this. So if this is slope m1, okay, this is m1, and this is m2. Okay, so since m1 is equal to m2, the two lines are parallel. The two lines are parallel. Okay, so it's all about the slope. So we come back here. So that has been worked out here. So just make y the subject and then identify the slopes. And since the two are parallel, the lines are parallel. Then we come here again, and then we have like a kind of word problem. So we have a kind of word problem in this situation. Okay. So a road is represented by the equation 3x plus 2y minus 6 equals 0. So this is a straight line. So another road must be constructed parallel to it, passing through the point 2, 2 comma minus 1. Now we already know that if we have a slope, a road is represented by this equation, right? Another road must be constructed parallel to it. So it means this other road is going to have the same slope as the first one, right? But then for this second road, now we know the slope and we know a point. So this can follow the point, the slope point or point slope form, right? So let's go and do that on the worksheet. Of course, it's solved here, but I think it makes more sense if I do it like that on the worksheet. So here now, the question is, we have the first row, that's 3x plus 2y minus 6 equals 0. This is road 1, road 1. Okay, so we can tidy this up and say we can get the slope. So we have 2y equals minus 3x plus 6. As if we transfer this and this to the other side. So you have 2y equals minus 3x plus 6, right? So divide 3 by 2, these two now, so that y can be alone. So you have y equals minus 3 over 2x plus 6 over 2, that's 3. So here now, the slope here, m1 is equal to minus 3 over 2. Okay, we need that slope. So for root 2 now, what information do we have about root 2? For root 2, all we know is that root 2 passes through, first of all, so root 2 is parallel to root 1. So that implies that m1 will be equal to m2, and that will be equal to minus 3 over 2, because they have the same slope, right? So this is really important. Then the second information we have is that root 2 passes through point 2 comma minus 1. And since we have slope and a point through which the road passes, what we just need to do is we take arbitrary point. So you have to take an arbitrary point x comma y. Okay, and since you have the arbitrary point x comma y, don't forget this is x1 y1. And with all of this in place, you can then go ahead and have y. Okay, or you say m, which is the slope. M is equal to y minus y1 all over x minus x1. Okay, we know the m already because since the two roads are parallel, the slopes are the same. So we have minus 3 over 2. Minus 3 over 2 equals y minus y1 now is minus 1. So that's y minus minus 1, because y1 itself is this minus 1. X1 is 2. So that's x minus 2. Then we have the whole of this. So we have minus 3 over 2 equals y plus 1 all over x minus 2. So it's always good to free y. So cross multiply. So you have 2 into, or better still, we don't even have to do all that. We can just say minus 3 over 2 into x minus 2 is equal to y plus 1. Okay, so the y is freed easily. So we then have minus 3 over 2x. Okay, then minus and minus is plus. And 2 cancels 2, so we just have 3 here. And this is equal to y plus 1. Okay, so we have minus 3 over 2x plus 3 minus 1 equals y. So y is minus 3 over 2x plus 2, like this. Okay, so this is the y equals mx plus c form. So you see the slope remains the same. Now we now have the intercept to be 2. Or we can also do it in the general form. To do it in general form, multiply through by 2. So you have 3y minus 3. 3y equals minus 3x plus 4. Okay? 3y equals... Oh, we are multiplying 3 by 2, sorry. That's my fault. So that is multiply 3 by 2, that's 2y equals minus 3 over 2 times 2. 2 cancels out. So you have minus 3x minus 3x. 2 times 2 is 4. Okay? So in general form, you can bring 3x, 2y is already here, plus 2y, then 4 minus 4 equals 0. So that's the general form of that equation. So this is the equation of that root, the second root that should be parallel to the first one that we talked about, that we were given. Okay? So you can use that idea of parallelism to take care of this. Okay, so now so that is what we solved here, but use it on the worksheet to make it clearer. So you can use this Python code to take care of that. Well, while this is not necessary, it may just help a bit. So it's just like an extra way of looking at it. So this is basically that here. So if you do these two lines, now you see that they are actually parallel to themselves. And this is the point towards through which that second one passes. So this is the original one, this is the second one. And one thing, if you want to plot this on Desmos, right, it's better you write it in y equals mx. So like make y the subject. That's easier if you want to plot on Desmos like that. So if I want to do this now, so the first equation, this is 3x plus 2y minus 6. So that's 2y equals minus 3x plus 6. That's minus 3 over 2 like that. Yeah, minus 3 over 2 x plus 3 for the first one. For the second one, it's minus 3 x over 2 plus 2. So in this case, now if we want to represent those two lines, so you can see that they are parallel, just like the Python code has shown. So the first one, just have y equals 2x. Okay, I mean, y equals the first one minus 3 over 2x, minus 3 over 2x, right, plus 3, plus 3. That's what we have there. Then, since they have the same slope, I can just copy and paste this. All right. And the other one is minus 3 over 2x plus 2. So you can see these two lines are parallel, like we saw over there. Okay. So that's exactly what we have here. So let's talk about perpendicularity. So what do we have to say about perpendicular lines? Two lines are perpendicular if they intersect at right angles, that's at 90 degrees. Suppose line L1 has slope M1 and line L2 has slope M2. Then L1 is perpendicular to L2 if and only if the product of M1. Of course, you already know that to get the slope of a line, if we know the angle of inclination, we take tan, right? So we have L1 is perpendicular to L2 if and only if the product of M1 and M2 is equal to -1, right? In short, okay, I think I can give a better picture when as I go to the worksheet later. So a vertical line X equals A is perpendicular to a horizontal line Y equals B. Of course, I think that goes without saying. So if I just have say I just have x is equal to 5 or x is equal to 6, and I now have y is equal to any constant for that matter. Maybe y equals 3. Okay, so you can see they always meet at 90 degrees like that. So they are perpendicular. Okay, that's a special case right there. So a constant uh, line on both axes will definitely intersect. So constant lines on both axes will intersect. That's the idea. So of course, before I even come to solve this problem, of course, as I go to the worksheet, I'm going to elaborate on this and then take care of this question. Check if the lines y equals 2x plus 3 and y equals minus half x plus 5 are perpendicular. So we want to check that. Okay, so I go to the worksheet now. So on the work on this page now we have so we already said that L1 is perpendicular to L2 if and only if the product of their slopes is equal to -1. That's -1. Okay. So what that means is that since M1, M2 is equal to -1, that simply tells us that M1 would be -1 over M2, or M2 will be -1 over M1. Okay, so if you have the slope of 1, to get the slope of the other, of a line perpendicular to it, has to be negative of the inverse of the first one, like that. So let's talk about that in some depth. So check if the lines y equals 2x plus 3, all right, and y equals minus half x plus 5 are perpendicular. So what do we do? They're already in the form y equals mx plus c. Identify the slopes. So here, this is the slope and this is the slope. So you have m1 equals 2, and m2 equals minus half. So check if they are perpendicular. And a simple check, just multiply the two slopes. So you have 2 times -1 over 2. 2 cancels 2, so you simply have -1. Okay? So with that now, you can just say, since m1, m2 is equal to -1, the lines are perpendicular. Okay? So we go back and check. We have like a word problem like before. So I mean, this one has been solved here. So I just did it on the worksheet. So for example, 4, a path is represented by x minus y plus 4 equals 0. So you want to construct a path perpendicular to it passing through 0, 0. So it's just like the case we had the other time, right? So you want something perpendicular to this one. So let's go to the worksheet. Of course, it's already solved here, but let me do a demonstration on the worksheet. So here we have a path is represented by x minus y plus 4 equals 0. Okay, so to know the slope, right, the first thing I want to do is say x plus 4 equals y. That means y is equal to mx. I mean, y is equal to x plus 4. That is the equation in the form y equals mx plus 4. I mean, y equals mx plus c. So that simply tells us that, of course, this is x. X is like 1x. So in that case, now we say m1 is 1. So the slope there is 1. Okay? So for a line, for a line perpendicular, to it, okay, we have m1, m2 equals -1. And since that one, m1 is 1, so we have 1 times m2 now. Because m1 is 1 equals -1. So m2 is simply -1. Okay? So since m2 is -1, so now we have m2 is -1. All right? And we have a point 0, 0 through which this new line passes. So this is like x1, y1. So we just pick an arbitrary point xy. Okay? We just pick this arbitrary point x1 now. Because whenever you have one slope, you have a slope and one line through which it passes. So you just now have slope to be y minus y1 all over x minus x1. So the slope now is -1, and that is equal to y minus 0 all over x minus 0. So that means you have -1 equals y over x. So that means y is simply minus x. In general form, that is, the x can come here. So you have x plus y is equal to 0. So you can say, of course, this x plus y equals 0 is perpendicular to that x minus to this now, it's perpendicular to x minus y plus 4 equals 0. So taking it back there, you can see the how to approach it using a Python code. So you can see I'm not dwelling so much on the Python thing, but you want to study it to see how that goes, right? So we see these two lines are perpendicular, all right? So I can also represent it on Desmos. So the first line is x minus y plus 4, which is equal to 0. And that is y equals x plus 4. See, that's it there. And then the second line is y equals minus x. So we have y, or we can even say, we can even write it the way it is, x plus y, okay, is equal to 0. So they are perpendicular at this point. So you see, perpendicular at this point, like that. Okay, so then we can consider extra examples. So here now we have two lines. You have slope 0.5, C1, C2 is 1 minus 3. So we have some two random parallel lines. So we also have random perpendicular lines like this. So we have n is 0.5. Because they are parallel, right? The slopes are the same. So we have slope 0.5 for two different lines with two different intercepts, 1 and minus 3. And for perpendicular lines now, we have m1 is 2, then m2 will automatically be minus 1 over m1. And then we have y3 and y4. So that's some like extra using Python now. So then we have these parallel lines, 0.5x plus 1, 0.5x minus 3. And for the perpendicular lines, we have y equals 2x plus 1, y equals minus 0.5. Of course, if the slope of one is 2, the slope of the other will minus 1 over 2. That's minus 0.5, like this. So that leads us to the practice questions. You want to try your hands on this. So we have 10 practice questions as usual. Determine whether the lines 3x plus 2y minus 7 equals 0 and 6x plus 4y plus 5 equals 0 are parallel, perpendicular, or neither. So you want to check that out. Then you want to show that lines y equals minus half x plus 1 and y equals minus 2x plus 3 are perpendicular. Of course, this is clear. The slope here is half. The slope here is minus 2. So minus 1 over half is minus 2. So they are clearly perpendicular. So you can try your hands on the rest. So with this, I come to the end of this interesting video on perpendicularism and on parallelism and perpendicularity. Okay? So try your hands on the practice questions so that you can get a hang of it better. All right. Let me know how helpful this is for you. And if there's something you'd like me to try out, feel very free to let me know. So if you have subscribed already, I must thank you. If you have not, of course, you want to go ahead and subscribe right away and hit the notification bell so you can always get alerted each time a new video is released. Having done that, you can take it a step further by clicking on the join button so you can become a member of the channel, and that comes with some special privileges. Ultimately, don't forget to comment, like, and share so that more people can have access to the great content I have going on here. Till I come your way again, keep doing maths right. Bye.